Hi, this is Miss Slitten, and this is my wonderful, excellent pie baking, cookie eating, period 2 honors biology class. Say hi.
It's my birthday.
Oh yes, there are multiple birthdays besides mine. We're continuing on chapter 33, which is population ecology, and we have already talked about biotic potential, right? When you can maximize your R. We have already talked about the 2 types of growth curves. Which type of growth curve would a large mammal be more likely to follow? Everybody tell me. Which one? Yeah, the S. What else do we call that? Logistic. Okay, a logistic growth curve. And then what's the other growth curve called? Exponential. Exponential and logistic have 2 things in common. Tell your bio buddy what those 2 things are. They both have a lag, and they both have exponential growth. Okay? Whose eat and drink for tomorrow we may die? Which one would be that one? Let's go. Make as many as we can. Exponential. Who starts to get, their numbers start to get slowed down by environmental resistance? Logistic. And then it tends to hover right around the carrying capacity. Good. Sometimes it's a little above, sometimes it's a little below. Then we talked about survivorship curves. Okay, what survivorship curve are we in? Type 1. So of the 1,000 offspring that are born, right, most of them live out their lifespan and die at the end of their lifespan when they're old. What's the opposite of type 1? Type 3. What kind of organism would fall underneath the type 3 umbrella? Plants, small insects, yes. And of their 1,000 offspring, most of them die, and a few live out their lifespan. And in between that is type 2. What would be an example of who would fall underneath a type 2? Bird. Perfect. Okay, so now that we've looked at that, we're going to start to study the human population growth just a little bit here. And if you look here, what type of population, which of those 2 growth curves does this look most like? The blue is the people. Follow the line. Look at it. Na 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 na. What type of growth curve does that look like? Looks like an exponential growth curve. And you can see that, look, there's the plague, little dip. You can see that was right after, can you read those words? They're really small. After the Industrial Revolution. Okay, better medicine, better housing, better sanitary conditions, and all of a sudden the population is exploding. Now, I want you to take a look. We're going to watch a video, and I'm going to pause this video while we watch it. I promise it's not too creepy, but let me pause just for a second. Okay, so after watching that video, what are some takeaways that you got from that video? Maybe something new that you learned. Yeah?
Well, help other people and you'll help yourself.
Ah, help other people and you will help yourself, right? Because some people might say, "Guy, those people on the other side of the earth that don't have enough food, don't send them any food. Just let them die. Because they can't support themselves and we'll be supporting them forever." But by helping them and helping their child mortality rate to go down, then their numbers will start to what? Even out, level off. You know, and as they start to develop, then naturally they have fewer child deaths, then you don't need to have as many children. And one thing that has been shown to really decrease population size, and maybe talk with your bio buddy, why do you think this is the education of women. The more educated women are in a society, the fewer children that they have. I'm not judging you. I'm not saying if you decide to have a family of 5 that you're an idiot. Okay, I'm not saying that at all. But I'm saying that as on the whole, the average number of offspring that you have, the more educated your society is, the more specifically your women, the fewer children they tend to have. Tell your bio buddy, why do you think that is? What are some reasons for that? All right, so tell me, why do you think that is? Why educate these women? Yes?
Because they might be able to get like a better job, like that pays better, so they can have a Like a smaller family, but maybe have like better things, I guess.
Okay, I like everything that, yeah, I like everything you're saying there, yes.
They know the financial issues that may arise, or they know they may not be able to handle having many children.
That is many children. What else? Anybody else? There are people working in countries that, like third world nations, and giving loans to women so they can start businesses. It tends to have a huge impact on it. They become more independent and more in charge of their own lives, maybe more educated on contraception and things like that. But you're gonna have cultural issues too, because there are some religions, and again, I want you to be sure to know, I'm not judging here, but there are some religions who would say that you shouldn't use contraception. There, sorry. That would be like wasting your seed if you did that. So you would have to be able to talk through some of those issues as well. Okay, so on our human population, usually countries are kind of categorized in two general names, and that is a more developed country and a less developed country. So taking a look at the picture there, where is the more developed country, on the top or the bottom? Top, okay? And you can see from this family, they have a couple of kids. Looks like they have some grandparents over here. Maybe they're working on a barbecue here, I'm not sure. It looks like a 2-story house, so they have plenty of room, looks like plenty of space. This is a 1-room house, and everybody is living within this one condition. And when you look at these two graphs, when you look at the more developed countries, their population size is leveled out. In the less developed countries, they're still up here. As we can ensure that these children are going to live, then you're going to start to see those numbers come down. And let's write some characteristics of each of these. Human population growth variation, less developed countries, Latin America, Africa, Asia, they are still in what phase of growth? What word would you use there? Exponential. The majority live in poverty. The majority live in poverty. Whereas in the more developed countries like North America and Europe, the growth has leveled off. The growth is leveled off, and people enjoy a good standard of living. All right, so when we look at our population right now per day, it's getting about 216,000 more individuals every single day on our planet. 216,000 births, which translates per year to how many? What's that number? 79 million. Okay, and actually this needs to be updated. The population was doubling approximately every 53 years. Now it's doubling every 56 years. What is that telling you? It's slowing down. Quality of life is improving. So on your notes it says currently, why don't you put 56 years? That's the doubling time. Do you remember last class when we talked about biotic potential? We said R equals, and we took what was the math that we did in order to see, what was that? Yes.
Birth minus death over total.
Yes, birth rate minus death rate over the total population. And right now, this, if we looked at zero population growth, discuss with your bio buddy, why did I use this picture? I combined a couple of pictures to talk about zero population growth. Knowing what we've talked about in that equation, discuss, go. So the number of what? Births equals the number of deaths. And this is how you see my love for you. Because what I had to do is I found this picture of 4 babies. Then what do you think I had to Google? Graves. But I wanted it to match. So I had to Google 4 graves and then had to search and search until I found 4 appropriate graves at spacing so it would line up with the babies. That shows you how much I love you right there, that lovely grave shot. Okay, so on your notes, you want to have zero population growth, birth rate equals what? Death rate. So during this time, when we have high population and we're having a hard time supporting them, it's definitely going to deplete our resources and what things we have. And this was just a graphic that somebody made kind of interesting about population and the planet. And they were saying ways to decrease population: accidents, murder, disease, famine. Maybe not the best ones: war, abortion. Over here, maybe better ways: contraception, small families, abstinence. And ways to increase the population initially, which we have found, if we have better medicine, better sanitation, better agriculture, it's going to initially it will increase the population because the babies are staying alive, but over time it's going to then what? Level off, right? Yes.
So this is like really harsh, but like, would you be able to say that natural selection of like, I guess, humans and like people who are in an extremely impoverished state would be a way to reduce the birth rate?
Yeah,
in
so
addition?
yeah, there's actually a philosophy called Malthusian lifeboat ethics, which says if you have a lifeboat, like think of the movie Titanic. Now, why he couldn't hang on to that board, I don't know. But anyway, if you think about Malthusian lifeboat ethics, what that is a philosophy that would say, if we have a lifeboat and we have all these people going down, we can't put everybody on the lifeboat because what will happen to the lifeboat? So just let some of them fall off for the good of the few that can fit on the lifeboat. So some would argue and say, don't help those people. If they don't have food for their children, just let them die. Survival of the fittest. The problem is, the reason why some of them don't have food is because of politics.
Yeah.
Because a warlord or something is not allowing that food to get to them in some way. But what we can see from this, what this video is proposing, which I'm sure is supported by quite a bit of research, is the idea is once we can keep their numbers up, yes, initially it will bounce up, but over time it'll level off and it should be worth it. Yes?
I know this is totally harsh, but like, just in the terms of like animalistic terms, wouldn't you consider, I guess, the kind of like ideal that like big politics and like big politicians who kind of inadvertently kill off impoverished people because they cater to the rich, wouldn't that kind of be like natural predation within?
Well, here's where you're going to have to think it through. And I can hear what you're saying. We as organisms, and some other organisms have it too, we have something called empathy, right?
Yeah, no, I'm.
Yeah,
that.
so I think in some ways we could deal with it just in a purely animalistic way, and we could just say, sorry, you don't have enough food, time for you to die.
It's not right. Like
Yeah, we have this idea of right and wrong, and so we don't like to have people suffer, or we come alongside, we kind of espouse kindness, some of us, not all of us, okay, espouse kindness towards others. There are some things we see in the news today, you know, I think I already had this talk with you, it's like so terrible what I've seen on the news. It's like, I will never have a tiki torch in my backyard or my garden again. Because now tiki torches, right? Doesn't it take on a whole new meaning when you see them used as weapons or, you know, carried in hate towards others? So that kind of thing, we do live in a world where people are oftentimes inherently selfish. But what I would argue is, let's say you are purely a selfish individual, purely selfish, only looking out for yourself. It is to your benefit to help those other countries, because overall that's going to decrease the population size. Also, it's to your benefit to help those other countries, because when people feel disenfranchised or marginalized, then that builds up resentment and anger, which then if you have some sort of weapon or bomb or car, you can use that in order to fight back, because that's the only thing you have. It's probably, if any, how many of you are older brothers or sisters? Any of you, the oldest one? What would your younger brother or sister do when they were really babies in order, if they were mad at you? They would just what you? Hit you, right? Maybe? I don't know. Maybe it's just my boys. My youngest son would get mad at his older brother, and he bit him. One time so badly, there were like teeth marks on my older son's back. And my question was, what did you do to him? Because it's not like he would just go, brother, you know. But he took something away from him. That was the only way they could fight back. He didn't have the words or the age in order to argue later, which he learned how to do very effectively with his brother, and knew how to push all of his buttons just to say, right? The people you care about the most, right? They can push your buttons the best. Why? Because they know you. They heard, and then a stranger saying something, when somebody you love or care about says something, it's totally different, right? Because they know you. So he didn't have the words to use as defenses, so the only thing he had to use as a defense was his fist. Now, I'm not saying it was okay for him to use his fist, and it's not obviously okay for somebody to use a car in Barcelona to mow people down, right? But that's what they use because they have no other weapon. And so it's to our benefit to figure out what's going on with you and try to help you in some way so that you don't end up selfishly looking out for my own interest, you don't end up blowing up a building. You know? So I think even if you were going with survival of the fittest, work it in that way. Well, it's to my benefit to actually not have all these poor disenfranchised people because they're going to get pissed and they're going to ultimately hurt me. Okay, so on your notes, strategies to reduce growth rate, I listed 3 down there. Could oldest BioBuddy take care of A and C and youngest BioBuddy take care of B? Go ahead. Oh, right, sorry. Okay, now, before we pat ourselves on the back too much as a more developed country, I want to go over a little something. Youngest BioBuddy, this is your graphic, this page. Explain what this page means. Go ahead, youngest BioBuddy.
Yeah, I don't.
Can you see it? This is population. Take a look at this picture. So who's the smallest percentage of the population? MDCs, more developed countries. Okay. So still youngest BioBuddy. Then explain this here. Hazardous waste production. Take a look at this graphic.
So bigger than
Let's see. So what percentage of the population are we? 22%. How much of the hazardous waste do we make? 90%. Okay, that should be a wake-up call to us. Okay, what are we doing? What kind of waste are we generating? And how does that impact our planet? Okay, and oldest BioBuddy, these are your graphics. Go ahead. All right, now we saw these age structure diagrams in the movie, and if you look, there are 3 groups: ages, pre-reproductive, reproductive, having babies, post-reproductive, done having babies, and you can see the different colors. I would like Blue, can you be the less developed country? Talk about yourself. Slate, you be the more developed country. Talk about how your age structure diagram is different. But Blue, you go first. LDCs. Yes, go get more water. Yeah. Are you going to go to one of those hydration stations? You would think, but we also have more industry. So we're using a lot. Like, we're using tractors to toil the ground. They might be using oxen. And also, we do a lot of packaging and transporting of our goods where they would just work out of the little environment. Does that make sense? All right. So, the less developed country, okay, this less developed country, when you see here, you have all of these in the pre-reproductive age, they're going to be moving into the reproductive age as they age, right? And then they're going to have even more babies, which makes the bottom of the pyramid, the base, it's all about the base, it's going to be even what? Bigger, right? And then until the pre-reproductives start having less children when they move into the reproductive. Okay? Whereas you can see a stable age structure diagram, this is where you're looking at a birth rate that's about equivalent to the death rate, and it's very, very stable. Yes?
So the reason for that gets smaller is because of the higher death rate, right?
Yeah, well, because they're having a lot of children because not all of them are surviving. So you're eventually going to get here, but it's when this group right here sees more success in this group that they have fewer children, and then this part of the pyramid is going to start to become smaller because they're going to have fewer children, and then you're going to transition into one of these age structure diagrams. So on your notes where it says age structure diagrams, 3 groups: pre-reproductive, reproductive, and then what do you need to put in there? Post-reproductive. And then women entering reproductive years versus leaving it. In LDCs, more women are entering. That's why you have a pyramid, continued growth, unstable age structure. That's considered unstable because you're going to keep making more and more kids. Whereas in an MDC, you have more women leaving. It's a column shape, and this would be a stable age structure diagram. Okay, now come to me just for a minute. It's funny, in my class 0 and now you, I sense a certain tiredness or exhaustion. It's like school has finally kicked in for you. And this Friday probably seems more exhausting this Friday than you were last Friday. Am I right? You're starting to come up on that curve where there are tests and there are quizzes, you know, and you're going to have a quiz with me next week, right? On Wednesday or Thursday. Okay, and so that's coming, that's right around the corner, and I understand that. And I just want to remind you, besides remind you that I love you very much, Lee, is that when I start asking you the questions in here, the ideal situation is to try to get 100% on these. And the reason is, it's affirming to you when you get them right, because you're like, I do know this. And that gives you a sense of achievement and accomplishment, and that you can master the material. And it can be disheartening if you miss them, even though you're not getting any points for it. So I want to encourage you to do your best on any of the formative questions that I ask. And when somebody misses it, it could be your neighbor or it could be somebody behind you, when they're missing it, really try to understand why they missed it. Try not to do it too loudly. Try to understand why they missed it and help them to understand it. It's good for your brain too, because if you can see, oh, they picked that probably this reason, but here's the better answer. If you can figure that out, you're less likely to miss it on a test yourself, okay? So do your best on these and have those discussions. Or say why I picked it. I got it right. You know, were you lucky about it or were you good? Did you really know the answer? Okay? So today, why don't we log in as something fun we're thinking about doing this weekend, something we're looking forward to that I can hear about. But let me remove some students first. Hang on one second. I got to remove second. Or 0. Okay, something fun you're going to do this weekend. Something fun you're going to do. Okay, let's log in. Let's not take too long so we can move along here. 31 of us. Yeah, 31, right? Am I counting right? Partying is on there. Okay, 2 more of you, hurry up. Let's go. Check your Bible buddy, make sure they know how to log in, because a couple people are still struggling. One person is struggling. Help that one person. Come alongside. May I assist you? Do you need help? Let me come alongside you. Okay, help your bio buddy who hasn't answered yet. Check. They'll have a smiley face if they answer. Partying, let's go. Eden, it still doesn't have you as in yet. Rachel.
Oh, I switched names.
Oh, okay. All right. So let's talk this through. 22. Most of you got it, but let's talk it through. If there are more people in the pre-reproductive stage of life than in the reproductive, more in pre than reproductive stage of life, then replacement reproduction will result in yes, okay? You're going to continue to increase in population size. Because as those babies grow up, they're going to make even more and go and make even more and make even more offspring. So your population size is going to go up. Yes.
Aren't there a lot of deaths too?
There will be a lot of deaths, but there are more births here. When all of these, let's say they're pre-reproductive, so they already got out of the baby stage, but there could be all different levels, right? When they move up, what that's telling you, even if you have some paring down of that group, there's still more going in than were in there before. So you're going to increase the amount of individuals that are reproductive, which means you're going to increase the amount of offspring again. Okay, check with your bio buddies, see if they got that or if they struggled just a little bit on that one. Okay. And now we've talked about a lot of these things, but now we're just going to stitch it all together. This is something you've actually learned already. Okay? We talked about the 2 growth models on the bottom, exponential and logistic, yes? And you've already told me, where would you see a smaller organism? In the exponential or in the logistic, do you think? Exponential. So you already know that. Animals that are like that tend to be opportunistic, taking advantage of the opportunity. The other ones are called equilibrium. Equilibrium because they tend to hover right at the carrying capacity. Who do you think tends to care for their young more? Opportunistic or equilibrium? Equilibrium. They tend to have fewer children and really invest in them. So all we're doing is kind of putting all of those characteristics together. So those are cockroaches. They would be considered opportunistic. And the part of the equation they're trying to maximize is R. They're trying to maximize their birth rate. They're trying to have it be as high as they possibly can to take advantage of that particular situation. And Slate, you are my opportunistic critter, okay? And I have some characteristics I would like you to describe to your equilibrium friend. So go ahead, Slate. Be opportunistic. they going for quantity over quality or quality over quantity? Yeah, they're going for quantity over quality. They're just making as many offspring as they possibly can and hoping some make it. They're not really, they can't care for all of them. They will literally have 1,000 offspring and hope some of them get through that. So on your opportunistic, you maximize their rate of natural increase. You tend to be colonizers. You tend to be colonizers. What type of growth curve do you have? Exponential, and give me a letter for that one. Oh yeah, you can use R, but think of the letter. What is it? J. There we go. J-shaped growth curve. You have all the traits, you reviewed them. Now E is going to be new, because I'm going to talk about it in just a minute, but I'm going to introduce it here. They tend to be regulated by density independent factors, and I'll talk about that in just a minute. Density independent factors. Just hang on to that, but it's a good place for it in your notes. All right, Blue. Blue, you are going to be the equilibrium pattern. You're trying to hover right around, what does that stand for? Carrying capacity. Okay? You tend to be larger. Okay? Like these Japanese macaws, and they're sitting in a warm pool. Why are they in that warm pool? It's freezing cold out there. The problem is there's really no food in that warm pool, so they have to get out of the freezing pool and then go get something to eat and then go sit back in the hot tub. Okay? So go ahead, Blue. You are the equilibrium pattern. Discuss yourselves. Okay, so let's fill in your notes right there. On your equilibrium pattern, their populations are usually near the carrying capacity. They are strong competitors. Strong competitors. They tend to be a specialist. So they're not a generalist, but a specialist. Who do you think tends to be a generalist? Well, I guess we can live in a lot of areas. The other one, if you're not an equilibrium pattern, what pattern are you? Opportunistic, good, okay? So they tend to be specialists, and they could become extinct when their evolved way of life is disrupted. What type of growth curve do they have? Give it a letter. S-shaped growth curve. And then their traits. You have their traits right here. You want to jot them down. Maybe beta, you can help with that. Large, long lifespan, slow to mature, produce few offspring. They care for their young. So they would be what over what? Quality over quantity. Exactly. And they tend to be regulated by density dependent factors. Density dependent factors. We're going to go over those factors in a second. I am thinking of a number right now between 1 and 100. Between 1 and 100. Don't tell me. Pick a number and tell your bio buddy. Whoever's closest wins. Have you got your number? You told your bio buddy? Whoever's closest gets to make the choice. Pass or play in just a second. My number? 51. Yes. Who guessed my number? Why did I guess that? Why did I pick that number? Because that's my age on Sunday. All right. Good. Nice. Oh, 20 for birthday. No, you're supposed to say, no, Miss Litton, you don't look 51, you look 20.
Yeah, 20.
Well, 20 is not accurate. Give me a little bit higher, but not 51. Okay, pass or play on differentiating these terms, abiotic and biotic factors. Pass or play. I'm giving you a long list there. Tell them out loud. Tell them the difference between abiotic and biotic factors. There's nothing you have to type. Just say. Okay, so riddle me this. Which factors are alive? Biotic. That makes sense, right? Because bio means life. Abiotic are things like water and light and wind, soil, pH of the water. These are not live, dead kind of things. They're just not living things. Very quickly, let's review what living things are, right? Living things are, do it with me, look up here, hands. Oh, you don't know this yet. Never mind. We'll learn it later. Sorry, it's a little song. Okay, so when we go back here and look at how populations are regulated, I was trying to figure out why you're looking at me like deer in the headlights. I don't know what you're talking about. When you look at how populations are regulated, some populations are regulated by density, just listen to the words, density independent factors. Meaning it doesn't matter how big your population size is, it just comes and could possibly wipe it out, like a hurricane. Right? Hurricanes don't just go where populations are extremely dense or not dense. It doesn't have anything to do with it. Hurricanes just happen. That would be a density independent factor. Okay? And so if we look at an example here, okay, when you have a tornado, tornadoes don't just go where a particular, it's not a factor of how big the population is. In fact, you hear about that. If that tornado had touched down in this bigger city, there would have been so many more casualties. Tornadoes just happen where the weather conditions are just right. So it is a density independent factor. Can it still regulate a population size? Yes. But it's not because that population was too big or too small. Density independent factors are usually what? Abiotic, not a living thing. Here is another example, a hurricane. It can wipe out a population, but it's not a factor of how big that population is. Flooding and conversely drought, that is a density independent factor, though it can still regulate. Now, things like mosquitoes and gnats, in order to breed, what do they need? Some water. Did you know that? And in areas where you have issues with like malaria or dengue fever, things like this, like in Puerto Rico, and dengue fever can spread. It's a hideous, terrible disease. Some people, when they have it, literally want to die. They want, and if they think they're going to get it again, it's unbelievable. It's just mental breakdown. It's horrible. And dengue fever is spread when you have standing water. So they work hard in areas like that not to have tires laying around that could hold water and make it easier for them to breathe. That is an abiotic factor that regulates how big that insect population is. It's water. It's not a living thing. It's a non-living thing, but yet it regulates how big that if they have a lot or not. But flooding and drought, these things not alive. But here, when you have this flood, you could have a small population or you could have a large population of them. It's going to wipe the same percentage of them out. The same amount of that population gets taken out. So on your notes, let's go to density independent factors. There is no correlation with population size. Okay, it's abiotic. And examples are things like flash floods, hurricanes, etc. Now let's contrast that with density dependent factors. Okay, these guys are massive. Okay, look at his butt right here. Look at those biceps and triceps. Now, why do you think they are fighting? Competition. It's over a woman. Okay, that's what it always boils down to. It's territory. I want to be the alpha male. Can you imagine if you were in that cage with it? Look at them leaping. They're like on 1 foot flying through. It would literally take one pounding and you would be out. You and I, which like our backs are broken, okay? Out. They are competing because they want to be the one that's in charge of that particular population. The more competition you have, okay, is usually because as the population size, what? Increases. There can be how many guys on a professional basketball team? Okay, I'm sorry, let me rephrase that. On the court. 5. Okay? Are there more than 5 people that want to play? Yes. So you have a lot of what? Competition. The greater the population, the more people that want to play, the more competition you will have. So density dependent factors, these type of regulatory factors do depend on the population size. Things like parasites. The more crowded and overcrowding you have, the easier it is for germs to spread. And that can end up regulating population size. When you don't, like, the diseases can spread very rapidly in cities and overcrowding if there's slum-like conditions. Those parasites have easy access to another organism, so it spreads more readily. Okay? Here, maybe they want a breeding area. Maybe it's over food or more likely over a woman. Okay? So before we answer these questions, let's put those down. Density-dependent factors correlated with population size. Do they tend to be biotic or abiotic? What? Biotic, exactly, biotic. Things like predation, parasitism, and competition. So biotic, predation, parasitism, and competition. All right, and here you go. There's 3%. Yeah. Can I get a pie? Okay, you got 4 questions. Keep cranking along there. There's a ton more. There's 4. Those are cute. If I braided my hair, it would look like one of your braids. Like have this much hair. But I never do it. Girls put the cute little hats on like when they're golfing and they have their little ponytail hanging out. They're like, I can't do that because it's like this much little hair all like in a little, it's sad. Oh, sorry, that's on film. Hi. I'll pause while you're working. Okay, so let's go over. See how you did. Close. Okay, 22 if you got this right. Identify the biotic factors. What does biotic mean? Alive or dead? life, right? Living things. Good. Nobody picked A, so that's good. Weather patterns are not alive. Did anybody pick D? Yes. 2 of you picked D. So sad. Okay. Weather is not alive. Shelter is not alive unless you're living as a parasite inside something else, and it would have said that. Okay. Shelter is like a cave. Caves are dead. But parasites are alive. Decomposers are alive. Give me an example of a decomposer. Yes.
Well, I just have a question.
Yes.
So the biotic factors is only everything that's like living.
What?
So for biotic factors.
Yeah. Remember we had those 2 columns, biotic, abiotic? So bio means life. Biotic factors are alive, and abiotic factors not a living dead kind of thing. Like water is not living dead. It's not a life form. If you say something is dead, like I wouldn't say that this pin is dead, because that would imply at some point it was alive. Yeah. Okay. What is an example of a decomposer? Yes. Worms. Fungus. Anything else? Bacteria. Those are decomposers. Predator. Give me an example of a predator. Yes. Wolf. Yes. Lion. Those are all predators. What is an autotroph? Plant. Okay. Tell your bio buddies struggle or celebration on that question. Go ahead. Tell them. Was it struggle? Did you capture it and put it in your notes? Because this would be something I would ask on a quiz. Capture it. Embed it. Oh, so close to 100. Okay, come back to me. You could put your questions, you could put them in the column on the right, or you could just capture them and put them all on the bottom as a review. Different strategies. Which of these is a density independent regulating factor? So it doesn't depend on how big your population size is, and that would be weather. Weather happens even if you're a small population or a large population. Competition increases as you have greater density, more numbers. Predation will increase. Size of the population increases as you increase. Resource availability, that would be a density independent regulating factor, because as your number of individuals goes up, you're going to have fewer resources. Okay, check with your bio buddy. Was that a struggle? Most of you it was not. There was just 2 of you who struggled on this. Ask them, were you one of the 2 strugglers, or are you okay? Go ahead. Okay, number 3. This was a thinking one, and I champion those 16 who figured it out. Good job. Yes.
So for A, small size, it doesn't mean of offspring, it just means of
Right.
the object itself.
Yeah. So this one says, which of the following is not a feature with an opportunistic life pattern? So that means it is a feature of somebody who has an equilibrium pattern. So that will help you. When you have negatives in a question, take the other end. That will usually help you, whether it's in my class or a history class or whatever. It's saying which of these is not this feature. That must mean most of them are that feature, just one of them isn't. So the feature it would be is more like an equilibrium in a K-selected. Are K-selected species small in size? No, they tend to be what? Large. Are K-selected species regulated by density-independent factors? Okay. Do they have a small number of offspring? Yes. So that's why you would pick that one. Yes?
Why can't they be regulated by density?
You can be regulated by many things, but usually the larger animals are more regulated by a density-dependent factor. The smaller organisms are more density independent. It's like, we have good weather now, we have the right water, we have the right environmental conditions, so we're alive, let's go, okay? They're not limited yet by space or nutrient availability, those kind of things. All right, check with your bio buddy. Struggle, do you understand it now? That's a hard one. They get it now? Okay, and an S-shaped growth curve, so let's draw it. What's my black line right in there?
Carrying capacity.
That's my carrying capacity. What stage is that right there? Lag. What stage is this right here? Exponential. And if this were an exponential, a J-shaped curve, what's happening in this region right here? Why is there a difference in this region right there?
This environment takes place.
Yes, that region right there is that environmental resistance that's slowing it down. Does that make sense? Okay, and so here what I can see is it says an S-shaped growth curve, which is the red one, occurs when there is no environmental resistance. Well, environmental resistance slows it down, so that's not true. Includes an exponential growth phase. Yes, there it is. Occurs if the survivorship is short-lived. No, they tend to be type what? 1, and they are what? Long-lived. Okay, and occurs in natural populations, but not the lab. No, we don't know that. Okay, check with BioBuddy. Did they get that right?
You get that right, sir?
Okay, now next thing, we are on competition, and we're gonna do competition, and then we're gonna stop, okay, and I'll let you blog. So let me just get through competition because I think you can understand it. All right, so competition is defined when members of different species try to utilize a resource like light, space, nutrients that is in limited supply. That is in limited supply. Now, these are squirrels competing against other what? Squirrels. So they're competing within their population. Do you see that, right? Population is the same species. What about this type of competition? Yeah, you've got two different species. Now, vultures are competing with vultures. I'm assuming there's something dead in there, okay? Vultures are competing with other vultures, that's for sure. But the vulture is also competing with a hyena as well. So you can have competition within your population, and you can be competing with other organisms for whatever that food is. And then this is where we need to compare and contrast these two words, habitat and niche. And could please my short-haired bio buddy explain to their long-haired bio buddy what is the difference between habitat and niche? Go ahead.
Habitat is like exactly where it lives, and the niche is like its jobs.
Okay, so they all live in this grassland, right? What's the role of the zebra who's dead? Yeah, he's gonna eat plants. Do you know what you call animals that only eat plants? Herbivores. Good. I am so glad you didn't say vegetarian. Thank you for being right. Okay? You're like, I was going to say that. You just didn't hear me. Okay, so they are herbivores. They are biologically built to eat plant material. Okay? The lioness. What would you call the lioness? Carnivore. A predator. Good. Okay? And the vulture. What would you call the vulture? Starts with an S. Scavenger. Good. Okay? What would you call the plant? Autotroph. So come back to me. They all live in the same habitat, but they have different jobs. I'm the herbivore. Somebody's going to eat me, but I'm going to eat plants. I'm the carnivore. I'm going to keep the herbivore numbers in check. They have different roles that they play, and that would be their niche. The issue comes up is when you both want to live in the same area. Now, do any of you have a dog? How many of you have dogs? Do your dogs get to come in your house?
Yeah.
Where does your dog sleep?
Anywhere.
On your couch. Can your dog sleep on your bed?
Yeah.
Okay, where does your dog sleep on your bed? On your pillow? Okay, that dog has privileges. Okay? All right? If they sleep on your bed, do you say, because you're two different, creatures sharing the bed, two different species sharing the bed, right? The dog, does he get to have his head on the pillow and you're down at the end of your bed like this? Chances are no. Okay? You have done some resource partitioning. Now you could do one of two things. You could be like, okay, we both want the bed tonight. I want it more, so I'm going to take a knife and stab you, kill my dog, and now I get the bed. Now,
I'm coming for you, Susie.
come here. Could that happen between two creatures? Yes. One lives, one dies. Or it could be like this. I sleep in the bed at night, you sleep in the bed during the day. That is resource partitioning. You're using it at different times. Or you could say, I sleep on this end of the bed and you sleep on that end of the bed. Also resource partitioning. Because here's the deal. You cannot sleep in the exact same spot at the same time and constantly fight each other because you're going to weaken. So there's something called the competitive exclusion principle, which says no two species can occupy the exact same niche indefinitely. It's not every single night. Maybe you do with your dog. Maybe you fight with your dog every night. It bites you, you punch it, and then whoever wins that night. Okay? But it's better. It is better if you decrease your competition where the competition you have is only near your feet. Right? So you can stretch out your feet and you're like going like this to move your dog. Like, that's where my feet go. You've reduced the competition to that small area. That is called resource partitioning. That would be better probably than killing your dog, right? Because you love your dog. Okay? So here, these two species grown independently are fine. But when grown together, one lives and one dies. So on your notes where it says competition, competitive exclusion principle, no two species can indefinitely occupy the same niche at the same time. Same niche at the same time. Your options. A, one replaces the other. One replaces the other. Or B, you do what's called resource partitioning. Could please, my long-haired bio buddy, explain how these barnacles are participating in resource partitioning. Go ahead. Okay, riddle me this. Are there two species of barnacles living on these rocks?
Yeah.
Are they fighting all the time?
No.
No. They've limited their fighting area. They've reduced it, this area of competition, to just this area right here. These guys say, I take the top of the rock, you take the bottom. Okay? Another example, resource partitioning. 5 different species of bird can live in one tree. But some have adaptations to live on the lower branches, some on the upper branches. Now, if we have this Blackberryan warbler, could there be many Blackberryan warblers all fighting for this one area? Could they have competition within their population? Yes. But this is their territory, okay? Where this other, the bay-breasted warbler, hangs out here. And the black-throated green warbler hangs out over here. That's called resource what? Partitioning. All right? So when this happens, species shift niches. They no longer directly compete. There's variation in timing, in areas, etc. And this is an example of character displacement. These are Darwin's finches. On the Galapagos Island, there was probably one parent finch species that came from the mainland. And there's, let's say, 1,000 of these finches on an island. Some of them had slightly bigger beaks so they could eat bigger seeds. Some had slightly smaller beaks so they ate what? Smaller seeds. And over time, These guys just focused on the bigger seeds, these on the smaller. If to be successful, the babies that lived and survived and reproduced all had big beaks over here, and these ones all had what? Small beaks. Slowly, their characteristic, their trait, differed. You either have a big beak or you have a small beak. Or you have a medium beak, and maybe some evolved where they could use sticks to dig insects out of the trees. And over time, you have all this character displacement, and you have several different species of finch, and all of that is done to reduce what? The amount of what they have with each other. Competition. There you go. So resource partitioning, character displacement, differences in morphology and characters in order to reduce competition. In order to reduce competition. In order to reduce competition. Here you go. I have a question for you. I have a question for you. Well, sorry. I thought something had to load on there first. I'm not sure what I was waiting for. When you're done with the question, could you briefly tell your bio buddy how you're doing with your Google site? What's it looking like? Is it hot stuff? Are you liking it? Okay, come back to me up here. Whoa. The struggle is real. Hashtag winter is coming. Okay, come back to me. I need your eyes up here because this one was a hard one. More people missed it than got it right. Okay? Scary. Okay, come back to me. Look at me. Look at me. You got 6 species of monkey. Okay? They're found in the tropical forest. Look, trees, trees. Hey, trees. Okay, trees. Okay, you got a canopy, you have different layers of forest, and you have different monkeys. It's a red spotted monkey. Okay. Oh, wait. And here's a blue monkey. I don't know. Okay. Now let's think through this. They're all living in the canopy here in this forest. Do they occupy the same ecological niche? No. Do they occupy the same habitat? Yes. How do I know they don't occupy the same niche? There's 6 species. I know because the competitive what? Exclusion principle says no what? 2 species can occupy the same niche indefinitely. Right? So I know they don't have the same niche. That would be like you and your dog fighting every single night for the same space on your bed. Okay? These are 6 different species. They do not occupy the same niche. Do they have the same habitat? Your bedroom? Yes. Do they have the same habitat? This canopy in the rainforest? Yes. But a different niche. And then B, eat different foods and occupy different ranges. Yes. You eat the nuts that are large, I'll eat the nuts that are small, you eat the insects. I eat the new leaves, you eat the old leaves. I eat the fruit that's on the ground. I eat the fruit that's up in the tree. All of that will reduce what? Competition. Do you spend much time fighting each other? Do the barnacles spend much time fighting each other? No. One takes the top of the rock, one takes the bottom of the rock. Just one area. It's where they overlap. Think about your house. You're the same species, okay? But it's the fence line. Maybe you argue with your neighbor over the fence line. I've heard of some serious arguments over fence lines, okay? Maybe right there is where you have your fight. But it's not like you're fighting over your whole backyard, just the one area, right? Because that's the boundary layer. Are from different stages of succession? No. We're not talking about ecological succession. In fact, we haven't even talked about succession. So we wouldn't pick that. So definitely we don't pick E where all of these are correct. Okay? Check with your bio buddy. Were they a member of the 12? The 12 tribe that got it? Or did they struggle? Discuss and clarify your thinking right now, your understanding. Have that discussion. And now, my friends, go find your blog site. Okay? Go find your blog paper. Think through. What is it? Talk about it maybe with your bio buddy first. What are some things you learned today? Put it out in your own words. Out.
That's what to say.
Out in your own words. And I hope you have a great day and a great weekend. And if you weren't here today, we super missed you. Make good choices.